Spotfire Data Science is a cloud platform for teams to collaborate on big data and analytics. You can build machine learning workflows with a minimum of code while leveraging big data platforms like Hadoop, Spark, and EMR, and traditional databases like Teradata and Oracle. You can easily spin up projects, share notebooks, promote insights, and of course, deploy models. I'm logged in here as a data science manager, where I have an overview of all the activity in the system. Everything in Spotfire Data Science is organized into these project workspaces, which contain all of the analytics assets created by the team. Here I can see recent activity on our project with the folks at Tipping Point. I can see an activity stream of everything that's going on in the projects that I have access to. And I've got an overview here of measures of activity over the last few weeks. The navigation items here on the left are a guide to the core components of the system. Spotfire Data Science is about people, anyone from data engineers to data scientists and business analysts and end users and executives. It's about people sharing data in the context of analytics projects or workspaces to yield insights, models, and other end user touchpoints. Let's focus on the data first. The platform is typically deployed against your existing enterprise data sources, whether those are on-premise or in the cloud. We can connect to most relational databases and all flavors of Hadoop, Hive, and Spark. I can easily browse these data sources, drilling down into folders and schemas, and start exploring the data that I have access to. I can see recent activity, get a quick idea about how the data sets are being used and what the contents of the data sets are. And then I can attach it to my project, wherever that is, so that I can begin a more in-depth analysis. At no point am I ever moving the data out of its source system. All operations in Spotfire Data Science are deployed down into the underlying platform. Now, because we're connecting live to all these systems, we can index the data sets, everything from column names to comments and notes, so that now my entire analytics ecosystem is searchable. If I'm about to begin building models for customer targeting, for example, I might search for relevant customer data. And here, in fact, I can see my data sets, say Hadoop files and tables and views in a database. But not just that, I also see other analytics assets, workflows, SQL files, Python, even scoring engines and entire projects. Plus, for each of these, I will see the activity associated with them. Now I'm going to drill down here to see a complete list of projects that are relevant for my search term. And I see that the team is already working on customer analytics and customer targeting. So I will select the workspace that seems most relevant to me based on its description and its activity. And I can now drill into this project to see what's going on. I can see the latest updates from the team here in the activity stream, and I can easily add or remove people from the project. And I can update project milestones here as well. Now, data sources can be global, or they can be limited to particular projects, which provides a very powerful way and a very natural way of controlling visibility of data in a way that leverages permission schemes at the level of the database or cluster, but now in the context of analytics projects. Here's a list of the data sets associated to this project. And here's the heart of the system where the work happens, code files and visual workflows for transforming data and building predictive models. Here's a visual workflow. Let me open this up into the editor, into the visual editor. And what this workflow does is it takes data from a relational form over here on the left, from a relational database. And it performs a sequence of ETL and data prep operators, all of which can be applied just by dragging them on from the palette of transformation and statistical operators over here on the left. Similarly, I can prepare data from Hadoop, applying exactly the same operators. In each case, they're very easy to configure, and the user doesn't need to care where the underlying data is. Here I specify my join conditions, which columns are interesting, whether it's an inner or outer join, and regardless of whether I'm sitting on top of a database or on top of Hadoop or Spark, it's very easy for me to apply these operations without writing even a line of code. And in every case, the operation is pushed down into the underlying database or cluster. So whether it ends up as here as a SQL join, or whether it ends up being pushed down as a Hive group by query for aggregating data, or whether it's a more complicated operation, predictive algorithm, an iterative machine learning operation that's deployed in Spark. In every case, the operation is pushed down so that we avoid data movement and thereby ensure scalability and security. We use open source where we can, but in every case, we ensure that the SQL and Spark implementations are safe and performant. Workflows and code can be deployed to schedule jobs to be run in batch, and those can therefore be set up on a schedule, and models can also be pushed to real-time scoring engines at the click of a button, so that predictive models are now available as REST APIs and with appropriate governance and approvals required before pushing those real-time models to production endpoints. Now, the platform is completely open and extensible too. So here's a workflow, for example, where we invoke a Python or PySpark function in the middle of a Hadoop-based workflow. And this can work with databases too, and with R or SQL or Hive code. You simply attach the code to the incoming data set and then write the code in a notebook. That notebook is itself versioned and managed and shared in your project workspace and is available to the rest of the team. Also, users who are comfortable writing Java or Scala code can add their own operators. These will appear on the left as available operators for sharing with the rest of the team. So your own custom algorithms and transformations, no matter how complex, can be shared with the whole analytics group as simple, reusable visual operators. Finally, these workflows can be deployed not just to the scheduler or to a real-time scoring service, but also as simple end-user applications. We call these touch points, and they are easily built from workflows using this simple wizard that ties user input elements to variables in the workflow. And then they can be deployed to a marketplace of simple web forms that their users can interact with. So in this case, we've published a mechanism for searching for hotel reviews based on a simple NLP workflow that we created. So, Spotfire Data Science covers all of the activities of an analytics team, from finding and transforming data to building and deploying models.